Alright, picture this. You're watching footage of a spacewalk, an astronaut slowly floating outside the International Space Station. Every move is precise. Every finger twitch exaggerated by the giant gloves. Their whole body is wrapped in what looks like a bulky, padded, futuristic marshmallow suit. And here's the question. Why is it so big? Why does it look like they're wearing 5 layers of armor and carrying an air conditioner on their back? Wouldn't it be easier if the suit were lighter, slimmer, more like something out of a sci-fi movie? Well, here's the surprising truth. That bulky suit isn't just a fashion statement. It's a miniature spacecraft. A life support system. A shield against one of the most hostile environments humans have ever dared to explore. Today, we're taking a deep dive, literally into the layers, of why astronauts wear such massive suits, what's inside them, and how they keep people alive in the vacuum of space. The suit is basically a one-person spaceship. Let's start with the obvious. Space is deadly. There's no air. No pressure. Extreme temperatures. Micrometeoroids flying around at kilometers per second. And dangerous radiation. That means if you step outside a spacecraft without protection, even for a few seconds, you're done. So, NASA designed the Extravehicular Mobility Unit, or EMU. That big, white suit you've seen on spacewalks. That's what it's called. And it's not just clothing, it's a portable spacecraft that wraps around your body. It supplies oxygen, removes carbon dioxide, regulates temperature, maintains internal pressure, blocks radiation, and shields you from space debris. All in one system. So yeah, it's gonna be a little bulky. No pressure, no problem. Why spacesuits need to be pressurized? One of the most important features of the suit is pressure. Here on Earth, we're under about 14.7 pounds per square inch of atmospheric pressure. In space? 0. Without pressure, your body fluids would literally start to boil. Even at normal temperatures, because there's no external force keeping them in liquid form. Astronauts would swell up, lose consciousness, and die within minutes. That's why the suit keeps them pressurized. But not to full Earth pressure, because that would make the suit way too stiff to move in. Instead, most suits operate at 4.3 psi, enough to keep the astronaut alive while allowing mobility. But here's the catch. Breathing pure oxygen at that lower pressure is essential to avoid a condition called hypoxia. Basically, oxygen starvation. So astronauts pre-breathe oxygen before spacewalks to purge nitrogen from their blood and avoid the bends, just like scuba divers. Layers on layers. What's actually inside the suit? The suit isn't just one big puffball, it's a stack of specialized layers, each doing a specific job. Here's what's going on. Thermal micrometeoroid garment, TMG, the outermost shell. It protects against tiny space bullets and harsh solar radiation. Pressure bladder layer. This holds the internal pressure, like a balloon wrapped around your body. Restraint layer. A fabric skeleton that keeps the suit from ballooning when pressurized. Cooling garments. Astronauts wear a liquid-cooled undergarment with over 300 feet of tubing. Cold water circulates to regulate their body temperature. Communication and helmet systems includes microphones, speakers, a gold-plated visor to block solar glare, and a bubble that gives astronauts visibility and protection. Primary life support system, PLSS, the backpack. This contains oxygen tanks, fans, scrubbers, batteries, and more. Basically, it's life support plus HVAC plus armor. No wonder it's bulky. Thermal madness. Space is freezing and boiling at the same time. Another reason for the suit's size? Thermal control. Space isn't just cold. It's wildly unpredictable. In direct sunlight, temperatures can reach 250 degrees Fahrenheit, 121 degrees Celsius. In shadow? Minus 250 degrees Fahrenheit, minus 157 degrees Celsius. That's a 500-degree swing, with no atmosphere to even out the extremes. So, the suit must insulate the astronaut and manage heat using a combination of reflective materials like the gold visor, the internal cooling garment, and heat exchangers in the PLSS. Without it, the astronaut could cook on one side and freeze on the other. What about gravity? Or rather, the lack of it. Fun fact, the suits are heavy on Earth, about 280 pounds, 127 kilograms. But in space? They weigh nothing. There's microgravity. Still, mass is mass. And that much bulk makes moving in zero-G tricky. Astronauts have to train for months in neutral buoyancy labs, giant swimming pools, to simulate spacewalks. Even then, maneuvering in that suit requires serious strength, stamina, and finesse. In fact, just donning the suit is a full-body workout. Radiation, debris, and the silent killers of space. Here's a threat most people forget: radiation. Outside Earth's protective magnetic field, astronauts face constant exposure to cosmic rays and solar particles. The suit can't block all of it, just the lower energy stuff. So engineers use layers of mylar, Kevlar, and other materials to deflect and absorb as much as possible. Then there's micrometeoroids, tiny rocks or debris traveling at 20,000 plus mph. Even something the size of a grain of sand can puncture a suit. So the outer layers of the EMU are specifically designed to withstand minor impacts and reduce the risk of penetration. That's part of why there's redundancy: 2 oxygen tanks, multiple layers, and constant monitoring of pressure and oxygen levels. Any breach? Immediate end to the spacewalk. Why moving in a suit feels like controlling a robot. Here's something astronauts often say: wearing the suit feels like being inside a robot. Every joint has bearings and hard rings. Final thoughts. So, why do astronauts wear giant suits? Because space is lethal, and that suit is a shield, a vessel, a habitat, and a lifeline. It looks bulky, but every inch is packed with purpose. To keep humans alive in a place we were never meant to survive. Next time you see an astronaut floating above Earth, remember, they're not just wearing gear. They're carrying the weight of decades of science, thousands of engineering hours, and the collective hope that human beings can explore the stars and come back alive. If you enjoyed this deep dive into the hidden science of spacesuits, go ahead and like the video, subscribe for more, and share it with the space fan in your life. And here's a question for the comments. If you had to wear one historical spacesuit, the Apollo moon suit, the orange launch suit, or the modern-day EMU, what are you picking, and why? Until next time, keep your helmet on, and your curiosity even tighter. Because space? It's unforgiving. But with the right suit, we make it survivable.